Okay. Okay, so we're live on YouTube. So hello everyone. Today Bilal he couldn't make it, so I'm asking the other Bilal to be a co-host just in case that I lose connectivity. Then you're not kicked out from the session. You will become a host, and then I can connect again. Okay. Are there any questions or topics that you want to address now? Jawahir, how is everything? How is your work going? Okay, just here there is a comment about, I mean, I see a few of you are interested to run Mnctp. You don't actually need to install Zojo. All what you need to do is to download the executables, whether it's on Mac, Windows, or Linux, and you run that. You don't need Zojo. Zojo, you will need it if you want to, for example, fix some issues. This is what I faced with the Mac version with Catalina. That is Mac 10.15, I think. Uh, there are things that do not work with Zoho. I mean, the allocation of the directories and so on. So I needed to go and fix that. There are a few things also I'm playing around with, but the bottom line is you don't need Zojo to run MMCTP. MMCTP will require configuration, so you need to make sure you have on a machine EGS properly installed. You need to have your Linux models also there and text data, and that's it. Okay, so this is regarding this comment here. Yeah, okay. Okay, so I need to run MMCTP on a standalone laptop. I already have EGS installed on my virtual machine, Ubuntu, that's fine. Please, how do I go about installation? So it's not, you just download MMCTP, but then you will need to configure it. And the configuration, you will need to, I have it here open. So let's say this. So the first thing you will need to do is you need to go to remote shell connections and define a shell. Okay. So here, for example, I have one to my virtual machine. I have a virtual machine, and the other one is on my Raspberry Pi cluster. What you need to do is you create a new shell, you put a title for it, it doesn't matter, it's just a name that you know which shell you're submitting. You need the IP, and you need I call MMC, I have a user set there, MMCTP, and a password. And I think this is important here. So let me show you just what I mean by that. So okay, let's share this. Okay, this is my virtual machine. I have my user, Abdel, which I usually log into. You could use, I mean, the user doesn't matter. But what's really important is, let me show you what I mean. Let me switch user to MCTP. Okay, you need to, the question is the prompt, this thing here. Okay, so let me go back. Okay, now for my user, I have something fancy and a prompt. So there is this tilde and a prompt. Basically, with MMCTP, a printout of this shell is actually, it looks at this printout and it will determine when a task has finished is when it gets a prompt. But how does it determine that the prompt, there is a prompt? With the tilde alone, it's not really a good way because some files might have actually that tilde as, in their name. So what you need to do is, this is my suggestion, is create another user, MMCTP, or in your user, I will just switch to MMCTP. Okay, and there is a bash file. Okay, so let's, if you look into on your home folder, these are the files. Anything with a dot, that's a hidden file. Okay, and there is a bash rc file. It's this one. So whenever a shell is opened, bash shell, it will automatically execute whatever is in that file. So let's do, okay, let's do it with Emacs. Sorry. Okay. Okay. So by default, Ubuntu has a long bash file that, I suggest you just delete it. And this is the important line. One important line is you need this export ps1 slash, there is a quotation, within quotation slash h colon slash w slash u dollar and then a colon there. This defines the prompt. How is the prompt going to look like? And basically, I'm telling the most important part is this here at the end. So slash u is for user, dollar sign. So basically, it's telling it the prompt to print the username, and that would be and then a dollar sign. So that would be the prompt. So these are, of course, this is the configuration for, or the setup for the EGS. That's where I'm exporting, defining where is my home area and so on. LSS is another file. If I want to make shortcuts, I like to separate it. You can make shortcuts. You can define your aliases here. For example, aliases, I just have one. So when I type Emacs, I don't want the graphical Emacs. So it's just an alias. So when I type Emacs, it actually executes Emacs space minus NW. These are basic Linux things, okay, for the bash. But the point is this thing. Now, you see, I have the user MMCTP dollar sign. If I went and changed, let's say if I remove this and dash, I don't get that. I don't get the username and then the dollar sign. You can make it anything. Uh, so here you can make it anything, but user dollar sign. Just give me a second, please. Yes, sorry for that. Okay. So bash, now I get back the prompt with MMC, the username. and the dollar sign. So this is something required for MMCTP, just so that it knows when a task has finished. Okay, so so this is what the line feed prompt is just putting the username MMCTP dollar sign. Yeah, that's what this thing is. You can then test the connection, and connection is okay. Now this is testing with the Raspberry Pi, but if I select my other one and I test the connection, it's also okay. These things you leave them as is, and the connection type. Sorry, this is for FTP. Usually with Ubuntu, you would use the second one, not the FTP, but the secured, I think this is secured copy or secure FTP. So use the second one.
Excuse me.
And,
This user MMCTP should be given the complete permission for the home folder.
well, it's a user, right?
Yeah, normally it is given permission only to the home folder, only a particular home folder.
Yeah, so it's to their home area.
Where
So
EGS resides.
okay, so let's share the stuff. Okay. So here it's just when you create a user. I mean, if you creation of a user is very simple. So you will type, this is my account, sudo wabder, and then I will type add user. Okay, and I give it a name. For example, test. Okay, then it will prompt. Okay, this is for my sudo. But then it will start to prompt me, what is the password I wanted for this user test? And then I will put some information. It will automatically then create in its home area. Okay. So under home area, if you look at home, okay. So each of the users I have on Linux has their, folder within slash home, and they're owner of that folder. Okay, so this is the folder name. It's MMCTP. I have another folder, EGSnrc. This is the test one that we just created. Okay, and wow. So it needs to have full, but it does not uh, matter. Well, when you, for example, so maybe I'm confused about your question, but this is the user, right? So I could basically put this as Wabder, okay, and put my password there, and that's it. And here, the problem is the prompt. My prompt is a bit fancy, but the connection is still should be okay. See, it's not detecting this because of my prompt. That's the problem. But as long as you have your beam defined or your eggs home is under that area, that's okay.
Yeah, that's specifically I want to ask. But this user should have the permission for that folder which contains EGS.
Yeah, yes. Okay, and all what you need is to access actually the eggs home right here at the end. So this is one thing also you need to define is the EGS folder path for all user codes. So for that user, when I log in with MMCTP, it will go to /home/MMCTP, and I'm telling the system, the MMCTP that look, all the EGS related files are under that home area.
Okay.
Another reason why I actually modify, separate, let's say my user from MMCTP, because you often need to, with MMCTP, if you want to use CT files, DICOM, the resolution is, or the dimension is 512,
Right.
512, and then you have the number of slides. So do you need to go to the DOS XYZ? Okay, let me go here. CD, Okay. So this is the home, the those XYZ under the MMCTP home area. You will need to, yeah, let's Emacs, and there is this file, user macros. So those XYZ underscore user underscore macros Mortran. This file, you will need to modify these three lines. Okay. So by default, I think it's 128, 128, 128. These are the number of boxes. Think of it of this way, the number of boxes in the X, Y, and Z direction. So for CT-based plans, you need to define to modify this one to 512. That's usually the CT resolution. And the last one to 512. And this is the number of slides. Of course, the problem is then it takes memory. Now, when you launch it, when you run it, it's going to take memory, RAM. So if you have, let's say 16 cores, but you have 8 gigs of RAM, or you're going to start to have problems because then it will probably need to use the swap. And if it's using the swap file, swap for memory, that's not good because that means it's just going to be very slow. So my suggestion is to keep another user, MMCTP. And now I usually put 120 here, but we now use a 3 millimeter slice thickness for our CTs. So I needed to actually increase this to 190, and I don't like it because then the parallel processing, I will be limited by the number of parallel jobs that I can do. That's the problem. But if you have, for example, like on my Raspberry Pis, for example, because of this issue, I had to actually define 3 slots with Slurp for each Raspberry Pi. Because if I put 4, then that's really tight on the RAM. Raspberry Pi RAMs are 4 gigs. So you just have to be careful about this. Okay.
Okay.
So once you modify the file, you need to then recompile those XYZ for that user. Okay. So let's go back to MMCTP. Okay, and here is then what's the batch you're going to use. There, for my virtual machine, I don't have Slare on there. I use AT, but on the Raspberry Pi cluster, I use Slare. And maximum running jobs, I think this is the default for. I would usually put this as the number of, if you don't have queuing, like if you're using AT, just put this the number of cores, or maybe less than the number of cores if RAM is going to be an issue. With the Raspberry Pis, or if you have a Slurm or NQS, because it actually has a queuing system. It will take the jobs, it will not execute them, keep them until it finds a slot and then launch it. So I usually put this 100, so it allows me to queue, to put everything, to put more jobs there on the queue. But running, they will just have to wait until a slot is finished, and then they get it. So this is what you need to do. Okay. The next thing is you need to then go to the configuration of your beam models. Okay. So I define, for example, a photon energy, a LINAC, and so on. These are just names. I define what's the manufacturer type, because as you noticed, some of like for example, the JAWS for Varian are different than for Electa, the component module itself. The MLCs, definitely, they're different. With Varian, you can have dynamic JAWS. Electa has different component modules that are used. So once you define your manufacturer, tomotherapy definitely has something different. I haven't done any simulations with tomotherapy. I don't have a model, beam model, and so on. But in my case, it's variant. MLC settings, these are the MLCs, and these are the boundaries of the MLCs. I don't usually put wedges because we don't use them. But the important part is here. So for the shell, I'm telling the system, Mnctp, the beam folder for that LINAC is actually under beam to beam. It could be a different name. Whatever name you have used, that's fine. You just need to put it here. They could be different names, although the machine, the LINAC, the way it's defined is identical, but it might be, for example, it might have a different name under the virtual machine than under Raspberry Pi. Then you need to put what's the beam name for that shell. This is important. This is an input file that the system, it's a template. You can think of it as of a template, and this is located actually, this is, okay, so I have my MMCTP configuration. I have them all under the documents. I have a folder called MMCTP. And there, okay, let me just, so these are the folders. As I mentioned last time, I like to split them. You could put them everything in one folder, but I like to have them each. So the Beam NRC, I've put actually a template file there. This is the template file. So you need to put that template file under the Beam NRC. And it's here, okay? The LINAC, this is the PIGS data file name. It doesn't need to be here, but that's actually on my Raspberry Pi or my Ubuntu. So it is there, the LINAC. I don't need to put it here, although this is something I really wish if one can actually use, because now the question is, what's the materials in this? I want from MMCTP to be able to determine or see what materials are available in that Exita file, but I can't. The second thing you need to modify CT models. The system comes with a CT model, a default CT model is called H2O RAM. And the idea behind it is that from the CT data, it will read the CT number for a given voxel and then try to put a material for that voxel with a given density. This is a water RAM. All the materials are water, and just, you know, it will just make different densities for the different CT numbers on the images. Okay, and yes, so this is actually one thing I wanted to do today, but we will finish this part. Any other questions?
What is the virtual machine actually defined in this one? Apart from the Raspberry?
Yes,
And there are two things. One is Raspberry 01,
yes.
other one is a virtual machine.
Yeah, I have on my laptop, I have a virtual machine, and I have a separate cluster in the network, my Raspberry Pis. So if I want to submit, for example, a calculation to go to the Raspberry Pis, then I need to, you know, select that shell to submit it to the Raspberry Pis. If I wanted to go to the here, for
So the virtual
example,
machine is the one submits the job.
it's the one I have on my laptop now. It's this thing. This is my
Okay.
virtual machine. This is not my Raspberry Pi. Okay, so
So
you
we
can,
we
for
need to
example,
define
have,
both.
what's that?
Do we need to define both? There should be a machine which submits a job as well as the cluster.
No,
They should be separate, or it should be can be single one.
no. If I don't want to use the Raspberry Pi, I can just delete it. If I don't have a if I don't have a virtual machine, let's say on my laptop, I don't need to define a shell for it.
Okay, okay, I understand.
Okay, but the question is, because the comment here is that he has actually a virtual machine on his laptop. Okay, so then he needs to define a shell for the virtual machine. And to get the IP for the virtual machine, uh, that is simple. So you just need to type IP HDR. So let me just exit from here. So here you type okay. So it will show you your network, and this is for my virtual machine. This is the IP. So 10.211.55.105. And if you notice, this is what I have defined for the shell. So here, configuration shell. So for virtual machine, this is the IP, okay? But the Raspberry Pi, that's on my network, home network. So it's a different IP, it's a different,
Okay, I understand.
okay?
Okay.
So it depends. You could, if for example, someone is struggling with Slurm, one way, but they have 2 or 3 computers, then you can define a shell for each computer. And then when you run shell calculations, each beam, you can submit it to one shell, to one computer. So the disadvantage is then you will be limited by the number of cores by that. So if a computer has, let's say, 10 cores, you have 3 computers, 10 cores, you cannot submit a job that takes advantage run on the 30 cores. You cannot do that. But you can take one field, submit it to the first machine, 10 cores, the second field to the second machine, 10 cores, and the third one, 10 cores. Okay? Which is not a bad idea, by the way. Okay. So I want to open a file. Any other questions? Okay. I'm not the chat. Okay. Okay. So let's open the. I think I have it somewhere here. I forgot if it's. CT calibration. So the water ramp is just a calibration curve. That does not really represent our CT, or how Eclipse, our planning system, actually translates CT numbers to water data. Okay, this is a this is our recent GE machine. We use the Cyrus Phantom, and we measured a calibration curve, and this calibration curve is actually what's in it and our Eclipse. Now we want to use this calibration curve with MMCTP. So there are big differences. Is here, for example, let's open the water run. Just configuration CT models. Okay. So with the water ramp, see only 3 parts of this calibration curve, but on our what we have measured, we have multiple linear segments, and we want to use that. So what we're going to do is then we're going to just select here. We're going to add a new model. Okay, I'm going to call this choosing plan. And the PIX data file, it's water. I can use the same data PIX data file that I have, Phantom. And now the number of materials. So we need to look at the number of segments we have. So this is 1, 2. So let's build it. I'll put 10 and then we will modify this. So everything is actually going to be water. This is how it in tank system translates or interpolates the city data, water. So we look at the first segment. The first segment is, yeah, I'm trying to remember what's, okay, CT number, CT. Okay, so we will take this first segment. Although it's not necessary. I mean, I could just start with minus 1,000, but let's suppose I want to do exactly this. So from minus 1,050 to minus 1,000, then the density, it's 0. I mean, I'm not going to put 0. I'm going to put 0.00001. Okay, so that's air, right? So here is just a linear part. It's not a big deal. Now, the second one is also going to be H2O, H2O, ICRO. Actually, just to make things quick, I'm going to copy. Okay, the second segment, it starts from minus 1,000. It's really the important one. Okay, minus 1,000 up to minus 815. And the density, we're going to put at 001. And then the density at minus 815. This is the density is 0.19. Okay, so if a CT number happens to be between these two values, is going to do a linear interpolation to determine what's the density of the voxel. It's still going to be, it's going to be water. Okay. Okay. Then we'll go from minus 815 up to minus 507. And this is going to be 0.19 and 0.4. This is our data. Okay, so you probably have your own data in your clinic. And then minus 507 up to minus 71, 0.489, 0.949. Okay, and then we have minus 71 up to minus 62. I think I have a typo here. 949, 0.976. Okay, and then I have minus 2. This should be 0, but anyway, I'm just going to take the same data. Because there is always uncertainty in the CT numbers that you measure. This is going to be from 0.976 up to 1. And then we have from 0 okay, now I know this should be minus 62 up to minus 2. Minus 2 up to 43, 1. So the first one, the low density, corresponds to the density for the lower Hansfield unit, and this is for the higher one. So 1.043, 49, and 1.052. Sorry, this is 49 and 241, 1.043, and then 1.052, 41, 880, and then I have 1.052. Okay, probably I need more, but let's put 12. Oops, it deleted everything. Okay, I wanted to 12. So I think you get the point. I need to put these, well, let's do it. So this one probably we don't need. Okay, now we put the densities. Okay, so now we have our model. So let me show you. I have actually got a patient DICOM anonymized. Does that has to do conversion for. So this is a dose distribution. The images are going to be now. Just give it a minute. Okay. Meanwhile, while it's doing, okay, it's reading the X phantom values. Okay, it's reading because I've already made these phantoms, but I will show you now what the difference. So remember, for those X, Y, Z, what we need to do, we need to create a phantom that's going to be based on CT. So as if we're actually making using the CT create command. So it's going to read the DICOM images. And then, if you remember, we had to go and then put, for example, what's the number of materials we want to use, and then define the Hansfield units and densities and so on. So when it does the CT, convert the CT to a phantom, those XYZ phantom, it will use that table to convert CT numbers into a material with a density. With those XYZ, with MMCTP, this is exactly what we have done. We have actually generated that table that's going to be used by CT Create to convert this DICOM into materials. And it has, I think, done that. So the 3D, the 3mmH, okay, let's wait. Okay. This, I think, by default, it's an option. You can ask it to create a phantom by default or not. I think it's here in the configuration, those XYZ. So when you make, so this is auto make. So you can actually take it off, then it will not create a phantom from the images. So for me, it's on. So this is created, and this is using the water ramp. It's just going to use the water ramp. Let's finish reading the dose. It's a big file because of the 190 slices this week, so it takes time. Let's try to do things. In case that you don't have the phantoms created, you can manually create this, and we're actually going to do it now. Okay, it's in the other file. Well, what you can do is, okay, let's wait because I cannot create a phantom until this is done finished. So imagine the number of data you have. You have for this plan, we have 512 by 512 by one, I think 189 slices. So it's a big file. It's downloading the data. Because I think an hour ago I submitted a simulation. It's a VMAT simulation. I wanted to know to see if actually I get a VMAT. I hope it's not going to. Let's, okay, somehow it got stuck. Okay. So this is the distribution from the first field, and I'm happy to see it's like circular. So it's actually did a VMAT simulation. That worked fine. Something happened. The second plan is not. So okay, let's generate. I will show you how to generate a phantom. So suppose you don't have an automate option. So we're going to generate. We still right click and generate a new phantom. And here, if you want to use the default, you just go to the last option, and and this is the phantom name. You can call it anything you want. For example, RAM. Okay, by default, it's called 3, but because I have one with the same name, it will not allow me. And this is the PEX data file. These are the materials, and basically, it's going to clean to contour. So anything within body is going to be water, and anything outside of body is going to be air. But it will the water will be adjusted for densities based on the RAM H2O RAM that we have. Okay, because I think this is where from here. This is the CT setting. I'm telling the system CT settings, use this model to generate the X phantom. So in that model, there is only two materials, air and H2O. And we hit generate. So now it's going to assign the voxels. It's going to assign a material for each voxel as well as the density. And we should get something identical to this. So let's look at, while this finishes, we can view actually the phantom. So this is it. Okay, this is just one slice, I think XY coronal image. So the grayscale represents the density, but actually the material, so if I select material, you're going to see two colors. Everything inside the body is water, and everything outside of the body is air. So I only have two media. But the density, the grayscale now shows the density. So here, for example, the density is 0.8, so it's here. Okay, so if I go here, it's 0.884. It got that conversion from the CT number. Here, the density, of course, this is for air. If I go to the lung, you see the density is lower. Okay, somewhere in the bone here, it's higher. But the material itself is still water. I hope that is very clear to you. Now, what you can do, if I used, okay, still assigning voxels. This is done once. So once you create the phantom, it's done one time only.
What is the use of that PEX data file then? If we have only the air and the water,
Yes.
what is the use of the PEX, defining a PEX data file?
Well, the PEX data file is the file that has the materials, right?
No, no, but
So
we have only two here. Actually, we are defining only the air or either air or water.
yes, but so the PEX data file needs to have air and needs to
Only
have water as a material, right?
okay, only two materials. Okay.
Okay, but the PEX data file that I have actually has more. Can have more materials.
We need not define bone, lung, or any other organs like that.
Uh, This is the next step. This is what I'm going to do.
Okay.
Okay, but the point is the CT ramp, the CT, the conversion, the CT table that we just did. You see, we did all the materials to be water, but all what we're doing is just fixing the densities.
Okay.
Now, the next step, okay, it's writing. Okay, so that finished. So the next step is, okay, I'm going to generate a new phantom, but now I don't want to use this default H2O ramp, but I want to use what we have actually generated now. It's still two materials, water and air. So there, when I go and hit generate, so we'll put this as TP. Okay, let's hit on generate. I'm gonna wait for some time. So yes, so here the materials still, we only have two materials, water and air. Why? Because when we generated the phantom, we used that ramp. The ramp only has water, and the air comes that anything outside of the body, you put that as air. Unfortunately, I cannot open both so that you see actually the densities are different. So for example, for a given voxel, the density might be different for this treatment planning phantom compared to our ramp, the default ramp. Why? Because we have modified a little bit or modified the conversion table. Can I generate one? I cannot generate another one. It's a slow process when you have CT data. And I think the problem is well, it's because of the number of slices. On the phantom that I have for the chamber, the number of slices are less. So this is relatively faster when you apply it there. Okay, we're almost done. So definitely, I mean, this is why then would you want to use Monte Carlo? Why do I mean, it's taking a long time, and I don't think there is going to be better accuracy with Monte Carlo or better or a difference, something significant difference than the FinPlan system. But the next step, and this is what Bilal wants to actually look at, is when we generate. Now, instead of using this CT, I don't want to use this. Okay, I want to override things. Okay, so for the example, the body, I want to override the contour of the body with the material. I could put that water as long as that material is in the PIX data file. Um, for the Ubuntu, I just created a tissue actually for my Ubuntu, but I have a problem in the simulation part. So I'm going to just use water, okay, for the body. So this is why I wish if we can, if for example, MMCTP, if the PIX data file is actually in you know, within MMCTP, and all of these are actually drop-down menus. I wish if that could be done. Okay, H2O. You don't need it for the Linux, but probably you will need it when you do the this part for the Phantom. ICRU, okay? And I'm gonna override the density. Just put the density to be 1. Don't use any CT numbers, just use 1. Okay, now for the bones, I know in that file, I do actually have bones, bone. So the contour, define bones, and I'm gonna put 1.85, fixed density. And probably for the lung, also, we're going to override that. So I do have lung. You just have to make sure that these materials, you have them in your Phantom, in your text data file. And this is going to be, I'm going to put 1.3. Anything else we need to change? I think this is fine. We'll leave everything. We don't need to override. So this is body, density outside, okay, clean, and then, so here, okay, we're overriding everything, and now we're going, so you see now the list of materials we have: air, water, bone, and lung. And I'm going to hit on generate, so we're going to put this as MMCTP. Okay. So we're going to wait, and okay, that's fine. You see, these are the bugs that, okay, yeah, don't worry about this. Problem with material index. I don't think it did the conversion. Let's hope it did that. Okay. So now let's view this factor. Okay, you see, it's a bit different now. These are still densities, but you notice one thing. Now the densities, I have 3 densities. This is 0.3. See, if you look here, just follow this. Everything, this is 0.3. Water or tissue body is 1. And if I go to the bone, that density is 1.85. Okay. And the materials, if I look at the materials, these are the materials. You see the bone, this is now bone, water, and then lung. Of course, the best thing, and then we need to, based on this, so if this is another way of, I mean, it's not an accurate thing because in tissue there are sometimes different densities, even with the bone and the lung. Different regions might have different densities, and that we can actually extract that information from the CT table, CT data that we have measured. So if we want to actually improve on this, then we need to go to the CT models and probably make a new model, okay? It's going to be similar to this. But now instead of water, for example, I could go and put, let's say I'm going to put the first two to be air, okay? And then the next two to be lung. And then I can put here water or tissue. If I have different types of tissue, I can actually, so if you have fat, for example, and tissue and so on, you can actually change the materials or the CT model. So instead of using water, it can assign a different materials based on the CT numbers. And that would be actually the best way to do it. Now, how to do this? This is the tricky part, and I did not actually work on it. But what I was thinking is to, for example, let's look at, so I'm going to put air here. So anything between minus 100 to minus 815, I'm going to put air. And the density, probably I can, this one, this is, okay, this is, I can put 0.1. Then between here and here, okay, or probably I need to actually interpolate between these two values to make lung, for example, room for lung, because otherwise, if I used lung between minus 507 to minus 71, you see that it's a bit a problem. So I need to actually, I would suspect lung should lie within between these two values. So then you need to assign, put that to be lung. And then here we can have water, for example, and then between 49 up to 241, or maybe something in between, you can start to have bone there, fat, maybe you can have it here. And so this part I did not work on, but probably I need to do some redefine these ranges for the materials and so on. I hope this is clear to you. And once you do that, then you can run the simulation. For example, you can run it based on water only. That's the treatment planning. And you should get something very close to the treatment planning system. And then you can run it with your new CT conversion with different materials. And that will probably be a more accurate distribution to what the patient is going to receive, because now we're using different, the appropriate materials. So instead of water representing all CT numbers, so we're defining different materials, different ranges, and so on. And then you can do the comparison. And this is the power of Monte Carlo. Okay? Any questions? So let's see if this runs. Okay. I'm suspecting this is not going to run because there was a problem with the Phantom. Did not assign the boxes correctly. See, now it's using the materials that assigning these materials, but I think there is going to, I tried to run it and it wasn't going fast enough. So I think there is a problem because these are 2000 histories. Why is it stuck? I don't know. So I have to go and see the code, why I'm getting this, why it's not assigning appropriately the materials or generating the phantom. Why did give me that error? By the way, if you have two shells, so instead of auto shell, then you can do this and just now select this other shell. So it will run the simulation on the other shell. Okay. And that was my point. Now, if you have two beams, I can, for example, the first beam, I can actually run it on the Raspberry Pi. And so I'll take this. And then once I've done submitted for calculations. Then when I select that, go to the second beam, I will go and select a different shell. Yeah, the beam works. Okay. Okay. How do we get CT calibration data? Okay. That is something you measure with the Cyrus Phantom or any Phantom. So the Phantom has some plugs in it, and the manufacturer will tell you the electron density for each material in the plug. So you scan your Phantom, and then you will look at the CT value, CT number for within that plug, and you correlate that to the density as given by the manufacturer. Any other questions? Singh, how is your research going? Doing fine? Are you still getting the circular field or how about you, Bilal? What are you doing?
I'm trying to actually complete my cluster and connect with this MMCTP.
Okay,
I got actually one more Raspberry. So now
okay,
I'm going to do it only with Raspberry, as you said,
okay.
not
The
combining.
problem, yeah, you see the issue with if you try to is when you compile, for example, those XYZ with if you're using Raspberry, it's a 32-bit application, and I think it might have a problem running on Ubuntu or the other way around. So you need to be careful. That's why you should actually stick to
Hardware.
one thing.
One architecture only. Okay.
Yes, one architecture. I think that's the way to do it.
I compiled, as you said last time, I compiled using the same this one, that PSA, BI, and other things, networking. I compiled the EGSnrc manually.
Okay. I use them. I use Docker to have websites and so on.
With the
Yes.
Raspberry Pis, actually, I could not get any NIS problems. Earlier, I was getting the NIS problems.
What's that for the Raspberry Pi? You were
I didn't get the NIS. I used to had actually a NIS problem connecting between the Ubuntu and the Raspberry.
okay. There is something maybe wrong in because I realized I had something. I had a problem with NIS, and then I realized I had. Okay, I'm going to check if that's a case in the presentation. Okay, calculation cluster, because for the NIS there is an IP. I think I had it wrong, but let me check if I fixed it.
There is one more thing actually I found in the presentation is that the C group configuration file is not defined there.
I did not put it.
Yes, exactly. It is not there.
Okay, so that's something I have to add. Let's check NIS, NTP, that's fine. NTP, NIS server. No, I had it correct. I actually put it correct. It's working. So the document is correct actually. Let me show you what I mean. Okay, here. This is in this line. I had actually put here the server IP, but that's wrong. This should be the network IP, so it should be 0. So I had the problems because this was, I was putting 11, for example, the server, and I was having a problem with the NIS. But then I realized this should be actually the network IP, not the server IP. So I just put this 0 and everything works fine.
Okay.
You also need to enable it, and you could actually get NIS. You could actually use Ubuntu as an NIS server. That's not a problem. You could for example, use your Ubuntu machine to export the home directory. That's not a problem. The
That's what
only
actually
issue
I'm doing.
The
That's what I'm
only
doing.
issue, the only issue is going to be that if you're defining your clusters Slurm with Raspberry Pis, because when you compile, so then for example, what you could do is you could put your Ubuntu to be the server, a Slurm server, but not to be a worker, not to be a client.
Okay. Yeah, yes.
Okay,
Yes. That also. Yes.
I think you can try that.
Yes.
Okay, back
Can I go to
to
that C group configuration that slide?
okay, because it's Slurm. Okay. This is
This is allowed
okay.
device, allowed devices configuration.
Yeah, devices, allowed devices. Okay. Yeah, this C group. Okay, I see your point. Yeah, I missed it. Do you have it?
I copied from the actually example folder.
Okay, because I do have it here. It's just nothing fancy. Just copy and paste.
There is a sample file available in the examples folder.
Yes. Okay, file open. Okay, the C group. Okay, this is it. I have it now. So let's add a slide. This is it.
Okay.
Okay, and then I will fix the slide, but for the time being, just copy and paste.
Okay.
Okay.
Thank you.
So, Singh, you're still back. You're still, you fix your problem.
Not yet. I am actually busy in some another project.
Okay. Okay.
I have just left with only the configuration with the Slum. Rest of the thing I have done. I have installed all the prerequisites on all my 3 clients.
Okay.
I'm left with the Slurm configuration.
Okay. For your work, I think it's important. It's good to actually have Slurm because probably you want to distribute, use all the nodes. If one using Mnctp is not really important, they can submit to each machine a different theme. But since you're doing Linux, stuff, cobalt, probably it's a good idea to use to configure slab. And it doesn't take time. If you just follow the steps, it's straightforward. It should be straightforward. Now, one thing for Bilal, I want to, because sometimes when you reboot, for example, when you, or you shut down and you come and look at the status of Slurm. Okay, so when you reboot, usually, so for example, I have Raspberry Pi 2 is down. Probably it's unplugged. Let me check. Yeah, it was unplugged when I moved. So just I'll give it some time to boot. Okay.
Like last time you said I used S control to wake it up.
Yes, and you can actually. So what I discovered also is you could. So you put update, okay, and node name. Okay, you can do this.
Okay, any number of.
Okay, so this will wake everything up. Okay, or I can put one, for example. Okay, and then I'll so state equals to item. Okay, so that should do it. So you don't need to do one by one for each node, because the Slurm uses this to define a group of nodes. You can use this notation.
I used to restart the services even every time I used to do that.
Yeah, but you can, as long as it's down. So when it is down, that is fine. Just issue this command. Okay, and put the name, and probably you have something in brackets, right? Okay. So you have them like number 01, 02, 03, and so on.
Yeah.
So you can wake them all with one command. Have you tried using Ansible?
Pardon?
Ansible. Have you heard of Ansible?
Yes, actually, there was a video I saw in YouTube.
Okay. Because for me now I have these 13 Raspberry Pis. Okay. I need to do everything through Ansible. So I'm learning how to use Ansible and so
on. Excuse me, I want to ask you some question.
Go ahead.
Before something.
Yes.
Okay, for X-ray spectrum, for simulation of X-ray spectrum, if there is any program to simulate, to calculate the simulation, software, any software, yes.
Not Monte Carlo.
Not Monte Carlo.
I don't know.
But maybe based on Monte Carlo.
I don't know. Because,
okay.
I mean, if you, because the question would be, okay, what's the model? For example, what's the geometry? Does the software?
Yes, the general X-ray tube.
Okay, I really don't know. Because I think the spectrum will depend on the filtration also. Remember that?
Yes, yes.
Okay, so.
Yes, you know, RQ2, RQ4, RQ, like that. You know, beam quality, different beam quality.
I'm not a diagnostic guy, but.
Okay. Because there are different, it is scientific X-ray tube.
Yeah.
You can generate any spectrum from diagnostic at any diagnostic range level. So I think it is well known. It is well known in this field. But there are some program called SpecCalc. I use it, but it has only three energy. Three voltage, three tube voltage only. You should pay for other spectrum. should pay to have a license of this program.
Okay.
So
Spec.
speak calc.
But you want the spectrum, or you want to
Yes, I want the spectrum. I want the spectrum only.
Okay. Because here EGS has, let's check what it has here. These are for megavoltage. Okay. This is 250 spectrum. I don't know what is that.
Yes.
This is megavoltage.
Yes.
This is
Yes.
megavoltage. This is bare cobalt, iridium, license.
Yes.
There is Mohan. Okay.
Yes, little diagnostic. I see little diagnostic here. Only 500.
Yeah, so
Only 250. Only that. Other is iridium source and cesium source, like
yeah,
that.
these are okay. What is here? What do we have here? Okay, I don't know what these are. Okay, these are probably isotopes. Yeah, I really don't know about that.
Yes. Thanks, Dr. Romy.
Okay, but what you could do, and my suggestion, because you're looking for something for a general spectrum, right?
Yes.
You could actually model just a simple X-ray tube, and
Yes.
then you can put filtration. Just look at a typical X-ray tube, how for example, the material. You don't need to be exact on this. And then
Yes.
just calculate and calculate your phase space file, and then analyze the phase space file to get the spectrum. That is because then you can modify the filtration. You can modify, for example, the energy of the electrons if you want to do that. The thing you need to look careful for is, for example, what's the thickness of these filtrations. If you have access to general manufacture data, for example, the materials and thicknesses, that's the way to go. Then once you have a model, then you can actually generate whatever you want, because you're looking for something general.
Yes.
Okay.
Yes.
So you can just have a general X-ray model and with a filtration, and then you can modify, for example, the incident electron beam, the thickness of the flattening filter.
Okay.
So sorry, the thickness of the filter, and so on. It's very, and I used to do this for my students when I was teaching. I was teaching actually a diagnostic course 10 years back, and this is how, for example, one can learn what's the effect of the filtration on the beam quality. So you can run the simulation and no filtration, analyze the phase space file, and then add the filtration, and then you can get the spectrum for both, and you can plot them together and see, for example, how this affect and so on.
But you should compare your results with experimental results. How to verify your code? How to verify your spectrum?
But I'm not doing this for example. Usually you verify it in order you want to do something else. For example, if, for example, one wants to study, let's say, a material for a detector.
Yes.
Right?
Yes.
So you need to make sure first that the model that you have represents a good X-ray tube. But if you're doing this for educational purposes, just to tell people, okay, what does a filtration do to you can do that. Okay. I will check if I have a model of an X-ray tube, let's say from a manufacturer or something, then I can forward it to you, and then you can.
Okay, thanks. I will send you email today. Thanks a lot, doctor. Thanks.
I lean towards therapy, because that's my specialty, but I'm trying to help people even with just learning how to use the code.
Thanks, Dr. Omid. Thanks. Really, EGSnrc is a story, a big story.
It is, yes, it is. Every time you learn something, you can. Yes. Once you you need to actually sit down and do something, and you're going to do
Yes,
it wrong,
that's true.
which is fine. Okay, then you're going to learn, what did you do wrong, what needs to be done this way, that way, and so on.
Yes, yes. Okay.
So, any other questions, or someone wants to share, for example, what they're doing, so that we can give them some hints if possible? Because I don't have anything else to talk about. Don't worry, if you feel shy, then I can just delete the YouTube. Don't worry about this.
Hello, sir.
Yes.
And my name is Awe. Thank you so much for your assistance and for your lecture, sir.
Yeah.
My internet has some issue at the beginning of the class. I was the one who asked the question. I've been able to install Zojo on my Windows,
Yes.
but I've not been able to download it to install it on my virtual box. So what I just want to be sure of is, do I need to still install the Zojo on my virtual machine so that I can be able to run it with MMCTP?
Okay. I addressed this because I saw it posted actually. So I
Okay.
addressed it at the beginning of the lecture, but I will repeat what I've said. You don't need Zojo to run MMCTP.
Okay, sir.
Okay. You download MMCTP, but then you need to configure MMCTP. For example, define, because your question was about you have a virtual machine and you have a Windows, right?
Yes, sir.
So then what you need to do is to configure. So first of all, in the virtual machine, you need to have, for example, your beam model there, the fixed data there. Everything should be configured properly on the virtual machine. That's related to EGSnrc.
I've done that.
Okay. Now for MMCTP, you launch it, and then you need to configure it. The first thing you need to do is to configure a shell. A shell is basically, where do you have your EGS? That's the basic question.
Okay.
Okay. Which computer do you have it? So the way you define this is through IPs. And if you open your virtual machine, okay. So this is my virtual machine. When you open it, just type IP ADDR. If you're using Ubuntu, if you're using a different one,
I'm
then
using Ubuntu.
Ubuntu. Okay, then you type IP ADDR. If you do this, then it should list to you the IP address of Ubuntu in this virtual machine. And in this case, this is the IP. The 127, this is the local. Don't worry about that. But look at this one. Okay. So this is the IP address, 10.2.1.55. Okay. Another thing, I've actually fixed it today. So I'm probably, you need to do this, maybe. So in MMCTP, let's close this. I'm going to share again the stuff. Okay. So when you run MMCTP, you need to go to the file. Of course, Windows will have something different, but there is under file configurations, you need to go to, first thing you need to do is to define a remote share connection. And there, you go to the shell login, and these are the shells or the computers where EGS actually is available.
Okay.
So you need to, for example, you can put a name. This is what I've done actually at the beginning of this session. If you look at the video on YouTube, you will find this is what I've done. And virtual machine, that's the IP I put. I put the username and so on. There are some comments I had regarding the username. Probably when you look at the video, if you did not get it, did not understand it, let me know, and I will probably explain it again.
All right. Thank you, sir. Thank you.
One thing very important. Okay, you need to make sure first. You need to make sure that probably the firewall, you don't have a firewall on your virtual machine.
Okay.
So with this, you can do it with sudo, okay, and then UFW disable. This is the firewall, okay,
Okay.
UFW. So I mean, since it's a virtual machine, you can just disable it. So now it's disabled, because otherwise you need to then configure the firewall that, okay, allow connection for this port and so on and so on. So the best
Okay.
thing, since it's a virtual machine, you need to disable the firewall. This is number
Okay.
one. The
Okay.
second thing is you need to make sure you install these packages, okay? Because I found on my virtual machine today, actually SSH server and client are not installed. I need a server, but I found, so probably you will have the same thing. It does not install it by default. So what you need to do is sudo apt install, and it's called open SSH dash server. I usually install both the server and the client. SSH client. So you issue this command. Now I have them installed. So
Okay.
that's because MMCTP uses SSH to connect.
Okay.
If once you have done these two steps, and you've entered here everything correctly, just put online and test your connection. You should get an OK.
Okay. Okay.
If you don't get OK, then it still cannot communicate with your virtual machine.
Okay.
Then let me know. We will see what you have done. We will fix that.
I will do that. So I don't need a special server outside my Linux and then actually my virtual machine and my system to run the MMCTP.
Yes.
Okay. All right. Thank you, sir.
So it's just I like to, I mean, my recommendation still would be to have a dedicated machine, because if this is on your laptop, then okay,
Yes.
you need to run a simulation. The simulation is going to take, for example, 10 hours. Are you going to keep the laptop on for 10 hours, the virtual machine? So even if you can get your hands on a decent, doesn't need to be like the best fastest computer, but if you can get your hand on something decent, 4-core, okay. How many cores you have in your laptop?
Is a dual core.
Okay, so you're already you're in trouble.
Okay.
Because the 10 hours probably going to take 1 day to run the simulation. Okay.
Okay.
So
Okay.
the best thing is try to get a machine.
Okay.
Okay, a machine, and through a network, if you can get it through with a network, because then you run the simulations on your machine, leave the machine, go home, come the next day, they should be done.
Okay.
Otherwise, on the laptop, because probably you're at, I mean, your laptop, you're going to school, university, and then when you travel back to home, you're gonna probably shut down the laptop. It's a problem.
Actually, I bought this laptop for the project. Well, it's because I've not been able to get the work very well. That's why I'm using the system for some other things. So if I'm able to get this thing very right, I can just dedicate the laptop for the simulation.
True, but then the laptop you're leaving it at university or at home or where?
It's personal system.
So you don't move it, you don't carry it, you don't turn it off.
I carry it.
Yeah, this is the problem. So if a simulation takes a long time, how are you going to keep the laptop on and walk with it? You can't.
I will need to adjust on all this based on your advice. If I
So,
can get the Raspberry Pi, I can move with it, but I don't think it's available.
No, Raspberry, don't get a Raspberry Pi. Raspberry Pi,
right.
okay, because it's still, if you want something powerful, okay, then you need to have multiple Raspberry Pis.
Okay, sir.
Okay, but a single one is really not worth it. Try to see, for example, if at university, if there is an old computer available, okay, try to take it and install Ubuntu on it and use it as the issue. You need to figure out the network part, because you need to probably have a switch for this thing, or the best thing is you actually have Ubuntu, and
Okay.
you install on the system itself, you install in it MMCTP for Linux.
Okay.
You could do that.
Okay. No problem, sir.
Okay,
I'll do
so
that.
think about this, about that. But if you still want to do it on your laptop, that's fine. This is what you need to do anyway, as
Okay,
I
sir.
was explaining.
The other question I asked is on the calibration curve for CT, because
Yes.
my MSc is on CT, so I'm trying to continue in that line for my PhD.
Okay.
So I don't really, is here, because I need to have the consultants those the calibration curve. Will I be able to get the calibration curve from him, or is something that can be generated on the computer that I will be able to download? The CT I work with, I think, is Toshiba. But out of the CT I saw on this MMCTP, there's no Toshiba, I just saw others.
But the calibration curve is something usually people, physicists measure, and they put this in the mechanic system, right?
Okay.
So usually, and there is a procedure how to do this measurement. Usually it's done at commissioning when, or maybe the vendor has actually a CT calibration curve. So
Okay.
ask, for example, if a CT calibration for the Toshiba, if in the department, if they have, someone has done the CT calibration curve for
Okay.
that. It's not, to be frank with you, it's not really that crucial, okay?
Okay, sir.
But essentially, why do you want, let's talk, why do you want to use MNCTP? What's your project with MNCTP?
Well, I want to work on those calculations for CT, computer tomography. I want to look at the how best to deliver those to patients during computer tomography scanning.
But computer tomography, you don't deliver those with it.
Okay.
You deliver those with a linear accelerator,
Okay.
usually, or a cobot system.
Okay. Okay, no problem, sir.
Do you treat patients with the CTs?
It is the consultant that treats the patient. I'm a physics person. I'm doing my PhD under him, but the consultant treats patients with CTE. Most of the time they do scanning. Maybe somebody who has a trauma
It's
to
true.
know.
You scan, okay, but how do you treat?
Sir?
But CT is for scanning, you get the images, right?
Yes, for scanning, yes.
But then how do you treat?
How do you?
Treat the patient. How are you going to treat the patient?
No, I do not treat patients. They only use it for scanning.
Yeah, so MMCTP is useless for you
Okay.
because it calculates doses, okay,
Okay.
and contours and gives DDHs and so on. So why do you want to use MMCTP? That's really, it might not be the right tool for what you want to do.
Okay.
Probably he wants to know the dose received by the patient during the diagnostic procedures.
But then how do you? It's the model that would be the problem, because in a CT, the patient is scanned, right?
Yes.
Here, unless you.
Well, during my in my MSc, we use an impact scan calculator, and we use TLD to look at the dose delivered to the patient. And the machine
Okay.
has a DLP and CTDI to give us an idea of the dose delivered to the patient. And we
Okay.
can now reconfigure that to know what exactly has been delivered to the patient. So one cannot be able to either to be able to do a proper dose delivery to the patient, either to reduce the KVP or to reduce the
Okay.
MAS in the
Okay.
subsequent dose to be
Yeah.
delivered to the patients.
Bilal, how good are you with the X++?
Sir?
Yeah,
No, I'm talking to
I can do actually a simple general phantom I could do it.
Okay,
And
because you cannot. Okay, so you cannot do your research with beam. End of
Okay.
story. The reason
Okay.
is the following. You can, for example, model the CT, no problem. Okay, CT, you can have a good model there. But the problem I see is when you do the scan, your patient is moving. With beam, we don't have a model that the beam is moving, you know, of sup-inf. The model with beam is you can have the beam rotating, okay, but the sup-inf, it's not really with beam.
The patient
Thing.
is stationary during the scanning.
Patient cannot be stationary with a CT scan.
the couch is moving inside.
Right? The couch moves, right?
Yes, the couch move.
Yeah, so the patient is not, with respect to the beam, with respect to the X-ray tube, the patient is moving.
Okay.
Right?
Okay.
So with the beam, you need to then make a beam model that the beam is actually going to, so now we're going to have the phantom fixed and we need to move the beam. We can make it this way. Such a thing is not available with the standard beam code, but it could be done with X++. You can then define such a thing. And I'm not really good with, I haven't done X++, but then you can define your source the way you want, that it goes up and down. How this is done, I really don't.
Okay, Dr. Rahim, I want you to understand my challenge. I'm still trying to put together my research statement. My consultant to work with a radiotherapy department that is in treatment of patients. So I want to gather the material that will be needed for the research work, and then I will now model what I want to do. But what I did during my MSc is the dose delivery with a CT, and then it still work with a radiotherapy as well.
Well, for radiotherapy, if you have something new with radiotherapy, the first thing you need to do is if you want to use Monte Carlo. Okay. First thing you need to do is you need to validate or generate a Monte Carlo model, a beam model that represents the treatment unit.
Okay.
If that is cobalt, if that is a MV Linac, or even an ortho voltage machine, okay, you need to generate first thing a beam model.
Okay.
So that you can use beam with it. You need to validate the model, and then the next step is, okay, I want to basically obtain something that probably I cannot measure. This is what's the power of Monte Carlo. Monte Carlo is not really, I mean, if you could measure something, that is, go and measure it. End of story. But
okay, sir.
True, because it's very simple. You measure it and so on. But the power of Monte Carlo is, okay, you can actually get results for something that is probably difficult for you to measure.
Okay.
This is one thing so Mnctp, for example, you can get better accurate dose distribution in the patient, or more accurate than what's actually produced by the tank system because of heterogeneity correction.
Okay.
Now, we cannot measure something in a patient. I cannot go and put inside a patient in each voxel in the patient, put a detector there and to measure the dose. I cannot do that. But this is something you could do with Monte Carlo.
Okay.
Okay. So this is, you have to think Monte Carlo. It's the power of it is you actually use it to calculate something that you cannot measure. But in order to achieve that step, you need to first validate Monte Carlo that it can predict what you could measure.
Okay.
So for a Linac, there are some parameters that PDBs, profiles, and this is you talk to the physicist, there they can give you the data, and then with the Monte Carlo, you can generate a beam model, and then validate. Okay, the Monte Carlo can actually predict what I have been measured, and I'm sure about that. This basically tells you that the model of Monte Carlo is good. The next step is, okay, I want to measure, calculate something that I could not measure. And that is something your research, you need to figure what is that. So what's the effect of this?
Okay,
What's the effect
okay,
of that? And so that's it. Okay.
Okay, sir. Thank you, sir. Thank you. Thank you, sir.
I have a doubt in actually this slum. Suppose I submit a job from the server. Is it there is any tool I can monitor that whether the clients are doing the job or not graphically?
Graphically, no, but I don't know if because I access everything with the shell. Okay,
Okay.
but there is this SQ. You know this
No.
SQ?
SQ, of course. SQ is there, yeah.
Yeah. So then you see that things are populated, things are.
But I have to issue this command individually in each clients, isn't it?
No,
Okay.
this is something you don't need to actually issue it for each client. Okay, let's try something. CD. Okay.
What I did was I used to actually first find the S info, then go to each actually client and issue a HTOP.
No, you don't need that. Okay, let me show you. Okay. So let's launch this. Execute. Okay. Okay. So now I'm going to this thing. I just want to make sure that it runs. No problems. Okay. It runs. Okay. So now let's submit it to Slab. Equals to 40. I think yeah, 40.
No need for putting the long there actually.
I don't need. I have only one queue. It's so by default it will take it. I don't need to put long. Okay. But if you have multiple queues, then you need to define the Q&A. Okay. So now when I do SQ, it tells me. So this job, its status is R. That means it's running, and it's running on my Raspberry 01. So I have 2 on Raspberry 01. I have 3 on 2, and so on. So you don't, and if you look at the S info, now you will find it is actually
Allocated, yes.
allocated. So you can, now to see, for example, I mean, there are a few things I don't like about Slurm. First thing is this, so when you do the top, I don't like the jobs to run with this nice value 0. I want it to go with the lowest nice value. Okay, because sometimes you're doing something else and you don't want Slurm to run. And I think there is a way to do it. I just don't know how to do this. So otherwise, I will then I need to renice it. So if I do top, okay, and I renice this to this job, I'll put it 19. So now this is running with the lowest priority. 19 is the lowest.
Okay.
Okay, I have to do this manually, but there is a way with Slurm to actually submit the job and run it with the lowest priority. Because if I have another thing that I'm doing, especially if it's a GUI base, then you want that to take full CPU and let the calculation run on the background. You want it to run only when there is nothing else going on. So this is something I don't know how to fix with Slurm.
I read it somewhere that if we normally if nice takes a default value, it has to be defined actually explicitly. Somewhere it said.
Yes, there is a way to define it. I just don't know how to do it with Slurm. I used to do it with NQS. But NQS now it does not run with latest Linux kernels. That's why I'm using Slurm. So this is one thing. What else I was going to talk about? I forgot what was my other point. So this is one thing I would like from Slurm. I mean, if one could,
But can we
see now
actually,
it's finished.
is it real time actually? This SQ only gives actually how many things are work is going on, but you can't take actually how much real time, how many work is taken up, how long it will take.
oh no, how long is going to take? You can't. This is why you need to do an estimation. That's why I run EX. I run just a simple, let's say 10,000 or 1 million. And then I make my estimation. How long I want to run this. Okay, I need to do that calculation. Slurm does not know, for example, when it's going to finish. Doesn't know. It's just keep. So let's run this again. And the progress of, if you want to look at the progress, you can look at the log file.
Okay.
You know that?
Oh, no, I don't. That's what we can. I
Okay.
just want to know how long it is, because how
Okay.
much work has been taken up. How much work? has
Okay.
been
See, when this is submitted, so jobs are running, right? EGS will create actually a log file. So let's look at this. So it should have the same name as your input, but then just put .log. So if you look at this file tells me some information. First of all, there are 14 parallel jobs. This number 14, because I submitted 14. This is the number of histories that were finished. And this is the number of histories remaining. Okay, so if I do it again, you see this number change, because now finished and this increases, right? So this will always decrease and this should increase. So I can see, for example, okay, how many histories are left? Or how, you know, I think I've done this for 100,000, and you know I can make an estimation. But the time, no, because that means that okay, it needs to know with the CPU, the speed, and so on. Usually the way, and my suggestion always, Bilal, is you submit. You know, I always submit, for example, 1 million, and then I go and restart the simulation. So I will go and Emacs, for example. Okay, I know the third, you see here, this one, I change it to 1. So the next time when I submit, it's going to restart. And probably I add a 0. So now I did 1 million. I'm gonna, okay, now I have an idea that 1 million, it took about an hour. Then if I put another 0, then okay, I'm gonna get more particles. It's gonna take roughly around 10 hours. So my suggestion is you increment. So the first time you submit, you put this 0, okay? And then go back, once the simulation is done, go back and modify this, put this to be 1. So it's a restart. Basically, if you want to use the GUI, you can use the GUI. I use the shell. It's faster for me. And this is the number of particles. I will add a 0, or I depends on, you know, if I want to add 5 times more, or you know, it's up to you. Okay.
And one more thing is that all your Raspberry Pis are headless.
Are what?
Headless, no, without any monitors.
Yes.
Okay, then actually you control everything from the Linux machine.
From my actually from my Mac.
Okay, MacBook. Okay, you control it. Okay.
Yeah. So you know how to.
No, I do. I control it from my Ubuntu machine.
Okay, that's fine. If you have Windows, you can control it from Windows. Just get Putty. Putty is a very good. Putty is a very good SSH drive. That's very good. I would suggest that. But actually, and I don't have monitors. I even when I install the application, I don't go with the GUI. I go with the light version.
Yeah. No, actually I install it in a SD card. Then actually I SSH it. Then I install all the remaining softwares.
Yeah, but even the version that I installed on so use it I use this, the imager.
Yes.
So here I use this application, you know, from imager, but the OS that I select, I don't select this. This is the default one. This is the GUI with the graphical user interface. I don't need that. I will go and actually install this live one.
Yes. What I did was actually for the server one, I with the actually GUI. For
Yeah.
the client, I with the only light version I installed now.
Yeah, yeah, it's up to you. Okay, I all of them, even the server, I put everything. The reason is I don't want the GUI to actually, because if it runs with the GUI, it will take some of the memory resources. I don't want that.
Oh, that's
I want the, because especially, even a server, you have some applications running there, so service running. One thing I tried is to actually, because the problem with Raspberry is 32-bit. I wanted to go with a 64-bit OS. I tried actually and managed to install the Ubuntu.
okay.
This is a 64-bit, okay? But the problem, I faced problem with EGS. It does not compile. I have a problem there.
I installed
So
Ubuntu twice, but actually I could not go up to the EGS. But even before that, I had some problems. So I had to delete it. I go back to the Raspbian only.
anyway, if you want, uh, uh, you you are at home, right?
Yeah, of course. Yeah.
So maybe we can set a meeting, me and you, or people who are interested.
Uh,
Bring the
yeah,
Raspberry Pi at
yeah,
home,
yeah. It's
and
here only.
then
Actually, I do everything from home. Actually, I have the Raspberry here only.
yeah. So then we can have a session. I can help you. We do this troubleshoot, and then we
Yeah,
get it
I would
fixed.
like to actually. I would like to.
Yeah. Okay. So maybe tomorrow, same
Tomorrow,
time if you
actually,
want.
I'm thinking of running this. My final, like, almost it is set now. Tomorrow, I'm thinking of running it.
Yeah.
So I'll actually get back to you. Actually, I'll just inform you.
So let's set something. We can do it together because I also have some stuff. I have four more Raspberry Pis to configure.
I have one more actually, but I didn't actually set it up now. I just want
Yeah.
to try with the one single server and one client version only.
Yeah. Yeah. Yeah.
If it works, I will add up actually more.
Yeah. Okay, then we spent 2 hours. I hope today I did not have a lot of things to to present. I'm waiting for to help people because I think now it's your time now. Bring your stuff. I've showed you I think the basics. Um, Definitely, I'm keen to also learn from you, learn from what you're doing and so on. Okay. So
Thank
I
you.
don't know, maybe next week we'll probably have the last session, unless people are interested to present their work and to have discussion with others. I will be very happy. But I personally don't have anything else to present from my part. Okay, in that case, thank you very much for attending today, and we'll see you then next week.
Thank you,
Inshallah.
Dr. Amis. Thank you.
Thank you very much. Okay. And Bilal, let me know when you want to do this.
Sure,
You
sure.
can do it. Okay.
Yeah, of course. Yeah. Sure.
Okay then. Okay.
Thank you. Thank you so much.
Master.